All right, so we know about bitwise operations now. We're doing cool stuff with the individual bits of a number. We got and, or, not, exclusive or. And now I want to talk about something completely different. Let's talk about the software development life cycle. And I've stolen a lot of these slides from the other wonderful computer science professor here, Bill Kearney, Professor Kearney. So thank you. Here is a fun little picture that kind of, I don't know, you have to zoom in or get out a telescope if you fully see this, but this is a silly meme example of kind of what happens when you become a software engineer. Like, there's so many different people talking to each other, and so much gets lost in translation. Like, this is how the real world works. If you're employed, you will both laugh and cry a little bit when you read this, right? So I guess the goal of developing software is to limit the amount of like potential issues and potential ways that people might confuse each other. Okay, so feel free to come back to this. It's a funny little picture and read it. Let's talk about how software gets built. What are the different competing ideas as to how to build a large piece of software? Like, I want to build PowerPoint. I want to build something important that a lot of people are going to use. So let's take it down to the basics, all up to completion, right? Like, let's say that you're the CEO of some software company, and somebody comes to you with a contract you've signed, you get a bid, and they're like, all right, here's $1 million up front. I'm going to give you a year to make this fancy piece of software that I asked for. Now what do you do? All right, let's figure it out. So here are the main steps. These all have to be done in some order. What people disagree about is the order. Here are the steps that, what people disagree about is like the length and also sometimes the order. Here are like the steps to create that software. Software development lifecycle. You got a bunch of new terms to learn. Okay, so here are the steps and their traditional order. All right. Sorry if this is small writing. There's a lot to show on one slide. So the very first thing you're going to do once somebody gives you money to make the software, they're going to you're going to spend 2 months not even writing any code yet. Actually, more than that. The first thing you're going to do is just figure out what in the world you need to create. All right, plan. You're going to gather requirements. What is required of this software? Analyze all the ways that those pieces are going to interact with each other. Like, go and talk to the customer. What do they really want? Go and figure it out, because usually humans have trouble explaining things, right? Go and figure out exactly what they need, because probably the first time they didn't explain themselves right? Figure that out. Figure out a bunch of use cases. You've heard that word before, hopefully. Use cases. How will the software be used? What are all the different features that I'm going to need to give to all of my programmers to implement? Right? How is the software going to be used? Let's try and draw some mock diagrams of what's going to happen. Right? That's 2 months. You have not coded yet. All right. Then, pretending that we have a year right now. Then the next stage, again, you're going to spend 2 more months still not writing any code. Then you're going to start designing the way that the code's going to happen and specifying everything that needs to be implemented now that you know exactly what the customer needs, right? You're going to write down in English, essentially. You're going to write documentation. What is this code going to do? Nobody's written it yet, but here are all the functions that need to be written. Here are all the classes that need to be written. Here's what they should do. Figure out all of their names, how they're going to interact with each other, draw diagrams. No code yet still, but you're making names of things, all right? Plan how each piece of code, every function, how is it going to be called by other people, who's going to be using it, how is it going to connect to the bigger picture, because at the end of the day, you have a giant team of programmers, right, with their own managers and all that. You're at the top. Everybody needs to understand what they're doing, okay? So there's going to be a lot of delegation. Plan it all out right now. Design, specify all the different names of the classes and how they interact, all right, all the functions as well. So that's another 2 months. You spent a third of the year now, 4 months. You have not written any code. That's what happens, right? This is the traditional way of doing things. Then you're finally going to write code, right? You've got everything planned out. Everything has descriptions next to it. You can finally shove it off to the managers, and they can shove it off to their developers. And you just hope that they followed those specifications right. And they probably didn't most of the time, right? We write bugs. So you're going to have to test that eventually. So you write code. You spend, a quarter of the year actually writing code, essentially. Does that make sense? That's what you have to do. And then just hope that it all worked out, but it probably won't. So you're going to spend an equal amount of time testing that code that was written. It's all been written, and now you have to test it. Generate tests, and go and make sure that every function and class and whatever, they're all playing together nicely, they're all doing the correct thing, figure out all the different edge cases, try to figure it all out, make sure they work together, make sure they work by themselves properly, and then just like get people to pretend to be the person who's paying you money, and like pretend to be those people who want to use your software and try to use it the way that they're going to use it. And come up with new edge cases, new bugs, and you're polishing the code for another 3 months. Okay, so you got 2 months left. What do? Then you finally, 2 months early, you're going to give it to the person who's paying you money. You're going to let them try out the software for a month, and then they're gonna notice like, oh yeah, you know what, I actually needed this instead of that, or they're going to find new issues because they're going to use something in a completely different way than you thought they were going to use it. All that fun stuff. And so then you're just going to like debug. They're going to find bugs. You're going to fix them. You're going to add more tests. You're going to create more code. They're probably going to ask for more features. You'll implement those as fast as you can. And then if the customer gives you a big long list of new things, then you're just going to restart this cycle. It's a big cycle. That's what this picture is saying. It's a big long cycle of software creation. First it's like, all right, figure out the requirements, design the code structure based on the requirements, do the implementation, test everything, and then evolve from there, right? So it's a big, long cycle, and it's never going to stop until somebody stops paying you, okay? Are there any questions about that? Because that's kind of what happens in the real world. What people disagree with, these are all the required steps. What people disagree with is the order of the steps as well as their duration, right? This is like the traditional order, though. Like in like a government facility, they're going to use this order a lot of the time. Okay? Does that make enough sense? This is a philosophical lecture today. Yes? Yeah. I'm sure you've done these things out of order as I've given you stuff to do, right? So this is what people have determined over the years is a good order, but it doesn't have to be the right order for your problem. Yeah. Comes with experience, though. So, yeah, this leads into different competing ideas, programming paradigms. What are ways that people like to program, right? The stage that I just told you with these amounts of times and things, that's called the waterfall programming paradigm. And everybody likes to hate it for some reason. This is like the old way of doing things, apparently. So the waterfall programming paradigm is to do those exact steps with that exact duration in that exact order, okay? So here's another fun picture that looks like it's from the early 2000s. Again, you're going to have the requirement stage, figure it out, specify all the things that need to happen, all the actual code, go and actually implement. Specification and design were together in the last picture. Specify design, code everything up, and then send it to testing, all that fun stuff. Okay, that's what's happening. So waterfall is the process of doing all those things in that order, and there are many pros and cons. All right, so everybody, waterfall is nice because everything is exactly planned out and specified. Nobody like is confused about what they're doing with waterfall. It's all written down, which is very nice, I would think. As a student, I'm sure you'd probably appreciate waterfall. So I've given you steps and plans for all of your labs. So you're a little biased right now, maybe. But there are a lot of cons to waterfall, and people like to make memes about it. It's just like people don't like waterfall for a number of reasons. It's a lot of time that it takes to do all these things before you get to code. As software implementers, you like to code things. So it's not very flexible, right? Waterfall is not flexible. You have to do this before this before this. There's no new order. If the customer comes to you 6 months in when you're in the implementation stage with a completely new design, you have to say, sorry, come back in 6 months for us to refresh this stage all over again, right? Come back in the evolution stage. If something changes, you just like, all right, you got to wait. Sorry, we're not in that stage right now. So that's an issue, right? Also, customers don't know what they want. As humans, we don't know what we want a lot of the time. And so it's hard to specify, and like you're just going off of what somebody said they wanted a couple months ago, which maybe changed, or they maybe didn't tell you what they really wanted, okay? So there's that. And then finally, like the programmers just want to program a lot of the time. And then you guys are good at things, right? If you were given a task by your boss, like do this thing, it was specified this way, go and implement it that way, you might notice that, oh, there's a much easier way to do that thing, but that does not follow the specification, and so now there's a clash. Or it would have been so much easier to do it this way. Something really needs to change right now, but sorry, that should have been dealt with in the specification stage. You're stuck doing it the bad way. Sorry. So it's very inflexible. That's what waterfall is all about, though. But there's a time and place for waterfall. Like if you're working at NASA on some very important Mars rover software, like you want it planned out very specifically, right? You want to make sure that everything is in its right, in its place, and precise. So it's good for mission critical software, I would say, where you do have the time and the money to take your time. Okay. So that's waterfall. Any questions about that? So it's essentially do all the steps in that order. You are forced to follow that order, though, which could be inflexible. All right. And so everybody's like, the new age people, they're like, we don't like that. Let us find a new paradigm. Let's make things easier for ourselves and faster. Let's mix things up. And they call it agile, right? Agile is going to do the same stuff. This is a new programming paradigm. It's the agile programming paradigm. It's like do the same stuff, but faster. All right. So agile programming paradigm, it uses the same exact cycle, all these things, but instead of months, we're talking weeks or even days. All right. So that's a little bit better. So it works in very small chunks. Like do the most important stuff first. There's a prioritization to it all. And so that's really good for like getting things out the door, giving it to the customer, right? And like having them tell you very quickly whether or not that is what they wanted. So that's really nice, right? So the pros and cons of agile. You're doing these steps very, very quickly, all right? That lets your clients, the people you're working for, see your stuff, give you feedback, and change their minds, right? So that's nice. There are also a decent amount of cons for the agile programming paradigm. Like you're working fast, you're doing these chunks of things very quickly. And that's going to lead to programming stages and design stages that happen like every month instead of every year. And so that might ruin some things. Like you might have I don't know if you guys read Hacker News or something. You might notice as a programmer, like there's this trendy new thing. I want to use this language that just came out, this technology that just came out. And if you get to have a specification stage every month, like you can start to like get lost in all the cool new shiny things that appear on the internet. So that's a con. You have to the manager has to rein the programmers in. And then also agile is perceived as a more stressful environment because you're doing all these things faster. Okay, so that's maybe bad for morale or for the actual implementers. It's perceived as more stressful because the time frames are shorter. You're doing all that stuff in like a month and a half or 2 months instead of every year. So that's a thing, right? That's agile. And so a lot of people like it, though. Their mantra is like, we're going to release quickly and release often, and that's going to help, all right? That's going to help everything. It's going to give us feedback much faster from the client, and it's all cycle-based, right? It's always like, do some stuff, then see how it needs to change, and do those things, see how that needs to change. So you're cycling quickly, and the client was probably happier because of it, okay? So how fast should you do this cycle? The question is, nobody completely agrees, but they say that the cycle of like design, specification, implementation, testing should be about a month, right? Cycles should be roughly a month. Some people do a 2-week cycle. Some companies like to do a 6-week cycle, stuff like that. And those cycles, they're called, a lot of the time they're called sprints. So lingo pops up with the agile people. And so in a sprint, like the whole team that's working on stuff, like they're working on getting a new feature out the door and like putting it into the existing software, making sure it works, plays nicely with everybody, testing it well, right? And then giving it to the client to be like, hey, is this what you wanted? Get their feedback and then do it all over again. So it's happening very quickly. You can't like make an entire piece of software at once, but you can make chunks. Okay, that's kind of how that works. Do the most important stuff first. So yeah, that's the main difference is speed with waterfall versus agile. The speed at which you do these things. All right, does that make enough sense? So that's that. You still do it in that order, more or less. And so let's compare waterfall versus agile. So the waterfall process, it's taken its time. It is attempting to predict what we need to do in the future, right? It's trying very hard to predict essentially a year in the future what the client really wanted and needs, okay? Agile, on the other hand, they say it's more about like we want to respond quickly to what's going on right now. So the question is, which do you guys think is the better option? Do you guys have any ideas? What are your comments about these two ideas? Like, would agile be too stressful? Would waterfall be too difficult, too long? Yeah.
I think the flexibility with agile, like still it'll be more stressful, but
Yeah.
because it's faster, your customers get to know that and know it won't be like 100% the perfect product.
That's
So
true.
that will let them know like fix these things and you can fix that.
That's a very good point. Yeah, exactly. Other comments? Yeah.
From what I know, is the later in development you notice an issue or something that could be done more efficiently a different way,
Mhm.
the more difficult that is to fix.
Absolutely.
rather than doing the entire system.
Absolutely. Yeah. So that's a huge con for the waterfall approach. You have to really hope that they did their design well. Good. Any other thoughts? Yeah, both of you.
I feel like waterfall and agile will combine. Like some stages don't need 3 months to sit on,
Yeah.
and some could be longer. Like I don't know, like a longer specification or documentation, or shorter documentation and a longer coding area, and then a longer testing. Like or just like being more flexible on
Yeah, and
how
that's.
much time you allocate.
I guess that's still waterfall, give or take a few months. I would say. But it's still like you're spending a decent amount of time, and then you're not going to the next stage until that other previous stage is finished. Yeah. Another comment up here? Yeah.
I feel like that depends on like which one like the team likes better. Like if you can like I guess like the stress and obviously like probably the agile's better.
That is very true. You have to like keep your programmers happy, but also you're in the business to make money. So it also depends on what the client wants. Do they want to see something quickly or not?
Yeah, because the thing is like all like with waterfalls, like if you put like too much time and money into it, and like the customer doesn't like or anything, it's like a waste. So it's better to do more stuff more quickly and like get it from like keep it like that.
Yeah.
More time.
In the waterfall stage, you can have some employee from the customer like be with you during all the stages and give input. Like that's a thing, but that's a great point. Yeah, they might not know, like that one person might not know if that's what's really what the company wanted after all. So there have been studies done on both processes. I hate that word, process, business process, but still, here's kind of what happened, what people have studied. Apparently, the agile approach, doing things rapidly, that same order, more quickly, is 200 to 300% more likely to result in a successful project versus waterfall. And by success, we mean the project finished on time and on budget. Didn't go over budget, didn't go over time. 200 to 300% more likely to be successful in that way. And so here is an image from the study. Again, this is really going to have to depend. I feel like this could be a biased study. I tried to look up where this image came from. I have to read the article now to see exactly what's going on. But here's a picture. Okay, so like they studied a bunch of projects using waterfall and a bunch of projects using agile, and I hope that they tried to keep the size of the project the same. Because like waterfall, like that's very common in large government projects versus agile is very common for like small websites being built by a small team. So hopefully they accounted for this. I don't know though. We'll have to really look it up. But here's what happened in this study. Okay, waterfall successful projects 14%. 14% versus agile, the projects that they studied, 42% of those finished successfully on time and on budget. So like, look at that amount, crazy. And a number of them, about the same amount though, per project, because humans don't know what they want. They were challenged, so it turns out that what the client was asking for cost more money or took more time to complete. So about the same amount of projects, no matter the process, are going to be challenged. We would say, like, because the customer doesn't really know what they want. Nobody does. But yeah, what happened here is we didn't take from the yellow to get to here. We took from the red. So failed projects are ones that just like we gave up. We've spent too much budget. We're just going to quit and not actually ship the software, something like that. So that is a very hopefully convincing I do need to go back to this study though. I think I found it on the internet, but I need to make sure that their methods for this are the same, because waterfall, again, is being used usually in like large pieces of software for the government and stuff like that, and agile is used by like startups and things. So that's not set in stone, but that's the common idea. Okay, so as long as they accounted for that, we trust this. We trust this image. Okay, any questions about that? Is that surprising? Or does that make sense? I don't know. I think I would just be more comfortable working in a waterfall design, honestly. Like, things are slower. I like to specify things. All right, so let's talk about like a subtype of agile that has become popular. It's called Scrum. It's a different kind of agile. It's doing all the things just quickly again, same kind of fast cycles, but they have their own new terms for things. Scrum is a subtype of agile. All right, so very popular. And so here's some new terms, yay, that the Scrum people do, and there's plenty of memes about this, of course. So what you do in Scrum software development, is you decide what it means when something is done. You have to have like, here's what everybody agrees means this feature is complete. So that's important. It's nice that they're going to write that down somewhere. Usually what it means for something to be finished is like the program passes all of the tests that we have written or have specified, which is nice. All right, so you have to talk about and specify what does it mean for every piece of the project to be done. So that's an important thing that you would want to take to whatever probably paradigm that you choose, but that's coming out of Scrum, which is nice. And then what you do is you make a big long list. It's called the backlog, a product backlog that holds all of the tasks that you need to do to finish your software. Okay, that's all you need to do. So you put into your backlog, it's just a big long list of tasks. It's a to-do list. You have new features written there. You have bug fixes, like that's another task. I need to fix this bug. Documentation can appear in the backlog. Like, all right, we need to document this, document that, because the user needs to like learn how to use the software eventually. It needs to be documented. Also for the code itself. And then every piece that you put in the backlog, everything that you are putting on this big long list, comes with a priority. Like this is priority 5, super important. This is priority 1, not too important, and everything in between. And then you also give like an estimated time to completion for that particular to-do task. It is hard though to like come up with, oh, this is going to take me a week. Like that comes with experience. It's just an estimate though. And then there's somebody who either is from the client or is like pretending to be the client. There's a lot of role play in Scrum. It's a little weird. The product owner, we're going to call them that. It's like the voice of the client. They're the ones who have the final say in the order and the priorities on that backlog. Okay, so it's either somebody from the client's company or somebody pretending to have the client's best interests in mind. So that's the start. And then there's more role play. It's very silly. So there's somebody called the Scrum Master, which is hilarious. And the Scrum Master is like the product manager, essentially, and they're going to guide the process. I hate that kind of corporate speak, but I have to say it today, sorry. It guides the Scrum process and just like make sure that everybody, like the people higher up and the people below, are all like on the same page, essentially. So the Scrum Master is in charge of the process itself, and they're going to have sprints. They call their cycles sprints, and they are usually quick in Scrum. They have like 2-week sprints usually, 3-week sprints. So at the start of every sprint, there is a little meeting, a big long meeting. It's called a planning event, where the highest priority tasks are taken off of the backlog. So here's your main backlog. It's your to-do list to complete your final software. It's like all the tasks that need to be done, and they all have associated priorities. Like this is priority 5, this is priority 3, this is priority 2. And you're going to pick from that and create a sprint backlog. All the things that we want to accomplish in these next 2 weeks. Which kind of makes sense, right? And then you're going to take the highest priority things, usually, put them onto here, and hopefully, by the time the sprint is over, you've checked them all off. So there's a big long planning event that like creates this backlog, and then it's off to the races. Everybody's working to complete tasks from that sprint backlog, all right? And then every day, every day at like the start, usually in the morning, everybody gets into a room together, stands up. It's called a stand-up meeting or a daily scrum, and everybody talks about like what they did before, what they were working on yesterday, what they're going to do today, and like any roadblocks, any things that are getting in their way so they can coordinate with other people, which is very, very nice. This is a very, very important thing, and they all stand up so that like the meeting doesn't get long. Like they all want to get out of the room. It's usually very short. They don't like meetings in Scrum, which is nice. And even if you're doing waterfall, most people do these meetings. In every internship I ever had, we did these 15-minute stand-up meetings where everybody's standing up. We're talking about what we're doing, what we did yesterday, what we're going to work on today. Like, even if you're using waterfall, people love to do this. Everybody steals this idea. It was a good idea. Okay? And then, yeah, just everybody is going to go off and work through their backlog. Like, they're all going to take pieces off the list, assign them to themselves, and try to check them all off. And hopefully by the end of that sprint, there's nothing left. And you can call it done and do it all over again. Yeah. I don't remember. I have no idea. I think just sounds like a made-up name almost. But Scrum. It comes from like rugby or something, doesn't it? Like a bunch of people working together to like move forward. That would be my idea. I think maybe it's from the rugby term. Would make sense, but maybe they stole it from somewhere else. No clue. But yeah, does that make enough sense? So here's like a picture of what's kind of happening in Scrum. So you got your main product backlog, all the tasks that eventually need to be completed for this final software to be shipped one day. And then you pick from that and you just have some smaller pieces, like you chop things off of the product backlog and you make your little sprint backlog, and that's what you're going to work on throughout your sprint, which could be 2 weeks is a short amount of time. Some people make it a month, doesn't matter. And you just keep on taking tasks off of that and trying to whittle it down. And every day you're going to stand up and talk to each other and coordinate and make sure everything's going right. And after the end of each sprint, you have a new chunk of software ready to be shown to the customer. You just keep on repeating from that until your product backlog is gone. Usually, like you give it to the customer, they add more things to the backlog. Oh no, new bugs to fix, new features to add. But eventually, it'll get down, and it becomes ready for a new version to be shipped out. And everybody's happy, right? That's Scrum in a nutshell. Are there any questions about that? Again, this is philosophy. This is like the way that people have chosen to do things that works for them, that ended up working for a lot of different companies. Okay? Who's to say that this is the right answer? But this is something that you should be familiar with by the time you get to industry, if that's where your plan is to go to. Because like this is what they do, right? And at the end of each cycle, every sprint, usually 2 weeks, could be a month. This is a picture of a month, who knows? There's also a meeting at the end. There is a long meeting at the start to generate the sprint backlog, and then there's going to be a retrospective meeting at the end where like people talk about like what went well, what went badly. Let's make sure like we got everything done. Was this the right amount of stuff to put in the backlog after all, or are we not ready to show this to the customer yet? And so it's just like they're trying to improve the process, which is horrible corporate speak, and I hate it, but that's why I'm in academia. Maybe you like it. I don't know. So, and then, yeah, they eventually give the product to the customer. Here you go. Give me new things for my backlog. Let's keep on track. Okay? You might notice, like, I've said a lot of numbers, like 2 weeks, 2 hours, 15 minutes. A lot of things in Scrum, and this is the reason why people, they flock to it and they like it, a lot of things are time limited. They call it time boxed, to make sure that, like, we all don't have to be in a room together for too long, because humans hate meetings mostly. Like the people down, the software developers, we don't like meetings, we like to code. So that's kind of the goal, right? Just try to keep our meetings short and like know when we're done. Have that definition of done as well, okay? I hope that makes sense. And so here's like a picture that you can kind of draw and everybody can see it. You can generate this from your backlog, and that's what people are like looking at to know, are we done yet? Are we done yet? It's called a burn down chart. All right, so everybody looks at this, like you can print it out in the morning or have like a place, like a place on the website, to the corporate website to see this. But here is how to read this burn down chart. All right, so the idea is you've got a bunch of tasks that people are working on, and so here's a line that represents remaining tasks to completion, and then every task had an associated amount of time. So there's like two separate axes. There's like task amount as well as hour amount, and so every task also had like an estimate of how long it should take. And so here's like an estimate. Here's like that being whittled down essentially. So you want both of those numbers, right, to approach 0. 0 tasks left at the end of the sprint, 0 hours of effort left to work on. So the ideal burn down would be this line, and you try to approximate that as you work on things. Okay, so the things that actually happen is like it takes a few days before like you actually finished a real task. So like the remaining tasks is like a stair step a lot of the time. So there's that. And then sometimes you notice that like your estimates for time, like here's the time amount of work left to be done. Sometimes your estimates are off, so you have to like add more time. Oh no, this is harder than we thought it was. But eventually you make your way down to 0 in both cases, and then you're at the end of the sprint. And apparently this is a 3-week sprint example, so like it's all over the place. People decide what they want. This is called a burn down chart, and the goal is like this is useful for managers, right? To see like are things being completed on time? Does this approximate a decreasing line or a line with a decreasing slope? Okay, so yeah. A lot of fun features. You've learned a lot of terms. That's Scrum in a nutshell. Does that make enough sense? Any questions about that? So a lot of software shops, even if they don't subscribe fully to Scrum and follow all their role-playing rules, they choose a bunch of features from it that they like. Like a lot of places, they have a concept of a backlog, even though maybe they're not doing Scrum itself. Okay, so that's a thing. Yeah, and that is a type of Agile that people tend to like. All right, so those are 3 main ideas: waterfall versus Agile, and then Scrum is a type of Agile. All right, there's one last one, and this is kind of the one that we're doing a lot in this class. I would say that we're very waterfall-y here with our labs. Like I've given you a bunch of specifications, but also testing is important. So there's one last paradigm that I want to tell you about. That kind of flips things up. All right, there's plenty of memes about it. It's called TDD for short. It stands for test-driven development. Okay, test-driven development. Scrum and Agile itself, they kept the cycle in order, right? They didn't disagree with the order. They disagree with the amount of time. TDD, test-driven development, disagrees with the order. They're going to swap 2 phases. They're going to swap the coding phase and the testing phase. Woohoo, that's different. And that's kind of cool though. So what they're going to do, if you're working on a project with the test-driven development paradigm, you're going to write tests before you write any code. You know the name of the function, you know what it takes, what it should give back. You're going to write tests for what should be happening right now before you actually write the code. That's kind of nice, right? It's kind of what we've done essentially in this class. What Zybooks has done for you as well. So you're used to this. And so there are some good reasons to do it this way. You're kind of forced to figure out how everybody's going to play with each other, right? How all the classes, all the functions they're going to be used, because you're going to give them dummy data, right? You're going to call them with a test, with a unit test. Like, if it gets these things, it should produce this thing. If it gets this thing, it should produce these things. And that's going to help you like figure out edge cases, which is nice, right? And also, like, how should we maybe implement this? I see a bunch of input-output pairs. Oh, I'm getting the idea that I should implement it this way with this kind of data structure or whatever. That's kind of nice. So I'm a fan of test-driven development. Many software companies are. It's not as popular as Agile, but I think it should be. And so they like to use colors. And so their mantra is red, green, refactor, essentially. And so before you start implementing everything, you have a bunch of tests, and they all fail, right? They're all red. So there's that. That's kind of like you with the labs or your Zybooks stuff. And then the more you implement, the more you get these things working, you get the tests to pass. They start turning green. That's kind of nice. Okay? And then once you've got the test to pass, like you've got the code works as far as the tests are concerned, you might notice that there's probably a better way to do this, or these two different tests can maybe be, like the way that I implemented them separately could maybe be combined. So you can clean up the code, and the fancy term for that is refactor. Refactor your code just means to clean it up, to add some documentation, stuff like that. Because usually you notice once you've got them all to pass, like I see the big picture now, okay, this is how it really should have been implemented. And then you go back to fix it up and keep the tests passing, right? And so that's what you do for every feature. You add some test cases first, and then you implement it. So it's always, their cycle is red, green, refactor. Red, green, refactor. Okay? So that's test-driven development in a nutshell. Write the tests first. I think that's a pretty good idea, right? I am biased, but it's useful. So there are pros and cons to this, just like everything else. The pros of TDD are like, if you have enough tests, it's called a test suite, that's your jumble of tests, right? If you have enough of those guys, then once you add new features, you implement new things, you still have all those old tests that should be passing, right? And so you can make sure that they do, because you still have them. You're going to run all of your tests, even every time you implement something new. So you can be very, very confident that what you just added to the code base did not break something, because you have all those old tests that should still be passing. And if they fail now, then you need to change something, or you know that you messed up, which is very nice. You have all that history of things, all right? And then also, this just comes with using like version control as well. Like if you break something, if something turns red and it was green before, it's not a big deal, because like everybody's saving the previous versions of the code anyway. They're using like Git and GitHub and all those things, if you've heard of those. And so you're kind of allowed to be brave. You can try something out, try to get this test to pass, and if it messes things up, then just like unwind, go back to the start, try it all over again. You're not going to ruin anything by being brave. So that's kind of cool. There are also cons to TDD though. Sometimes you've written a lot of tests. That's good things, a good thing and a bad thing. If you have a bunch of tests that need to pass before you know if what you did was correct or not, you kind of have to run them all and wait on it. So there's usually like there's a big server farm at your software company that's just like continuously running tests, right? Called continuous testing or continuous integration. And you maybe won't know until the next day if like you messed something up, because like it takes that long for all of those tests to run. Like, there's a lot of them. People are writing a bunch of them. So there's that. That's potentially a con, potentially a pro, depending on how you look at it. Just like it's a matter of time. And then another con, and this is an interesting one that you can fix. Usually it's the case that the programmer who's implementing this new feature, like I want to add this functionality to the code, they're the ones who are also writing the tests first. And that's sometimes a bad thing, because the person who's writing the tests might miss something. The person who's writing the code and the tests at the same time, they might like have some blind spots in their code, or some blind spots in the test. Like you're forgetting to check this thing, and then if you're the same person who wrote the test implementing it, you're like, you don't see any problem. When if you were to separate the two, have a different person write the test and a different person implement it, you might more easily notice that there are issues with either the tests or the implementation. Okay, so that's the thing that can be fixed with more humans. And another con is you have all these tests that you work so hard on. Sometimes your requirements change, or the code needs to change. You need to refactor a bunch of code, or the customer gives you some new requirements, and that changes how things hooked up before. The tests used to pass, but now with this new idea, this new requirement, your old tests fail, and you have to update them to reflect the new changes, the new ideas, the new requirements. That's a problem, okay, that you have to worry about. And then finally, it's sometimes hard to test something. Like some things are like intangible, right? You can't test an experience, like write a test case for, was this game fun? You can't have that run by itself, can you? You have to play the game. Or like a graphical user interface. Was the graphical user interface easy to use? You have to have a human to run some of those tests, right? So, cost money. So those are pros and cons of TDD. Does that make enough sense? It's a different kind of paradigm with its own pros and cons. And probably the moral of today is you should pick and choose from the different paradigms to like match what you think you need. I think that would be a good idea if you're ever a CEO at a software company one day. But yeah, do we have any comments about this one? Any questions? Because I do want to write some code finally. I'll give you a TDD example, but does it make enough sense for now? All right. So let's make some. This is also coming from the bitwise lecture above it. So let's make a test-driven development example. I'll walk you through the process for some bitwise operation functions. Right. So let's plan. Right. Here's what's on our backlog. We want to make these two functions: set third bit and check if the third bit was set functions. All right. So let's say that somebody's going to give us some numbers and we want to check if it's set. Like somebody gives us a number x. We want to either set it, make sure it's set to a 1. Set means 1, by the way. Unset means 0. And then check if it was set. All right, like returning true or false. So kind of here's what's going on. Somebody gives you a number. Some int or something. We're going to take an int, let's say. And what's bit 3? This is bit 0, 1, 2, 3. So it's this one that we care about. So is third bit set? If we give it this x, it should say false, return false, right? Because it's not set. But the function that sets the third bit should probably take the number by reference. You want to go in here and change it from a 0 to a 1. Make sure it's a 1. Okay? That's kind of what we're going to do. But the start of it will just be we're going to write tests. And we're going to need some implementation. We're going to have a dummy implementation that's called a stub, remember. Just a function implementation, just like appeases the compiler, but is completely incorrect. Right? It will compile, it has a body, but it does not do exactly what it should. We'll fix it by getting the test to pass. Right? So here, let me connect to my terminal here. It takes a second to spin up. We are lecture number what? Lecture 27, I think? Yeah. Alright, so we want to make a file call. Let's do tdd example.cpp. And so I want to make the following two functions, and we're going to test them. So it's going to be called set third bit and is third bit set. And so set third bit should take a number like an int by reference because we want to change it. And so it's just going to be a void function. Just does the change to the thing that was passed to me. And then is third bit set should take a number, not by reference, just a normal number, and return true if that third bit was set to a 1 and false if it was set to a 0. Okay? So those are the two things I need there. And then I also need to write some tests, right? So I'm going to need assert true. And I don't remember. I want to copy and paste it from somewhere. It looks like lecture 15 main.cpp. There we go. So I'm going to steal this. Cool. Oops. And let's go back to today's lecture. 27. Cool. All right. So there's the file. I need the string library. So essentially you did TDD if you did my AI extra credit opportunity. All right, so let's make some tests for both of these functions first, right? We're going to start their implementations out as stubs that fail those tests, okay? So these are the functions. These are what they should look like. Let's make some tests for them. So we'll make a test for, or even a couple tests for test set third bit. I'll just have some tests inside of it. And then we'll make another function that has tests for is third bit set. All right, so can I show this to you? So there's assert true and the two function signatures. Those are the things we're going to implement. All right, so assume we have them. Let's write the tests first. What are some good tests for some numbers? Let's have a number. Let's have a test for like set third bit and is third bit set that have some numbers with the third bit set and some numbers without the third bit set. So let's have a number with the third bit set. We're going to need like an example number eventually. So let's do this one. This is 0, 1, 2, 3. There's bit 3. It's set. What number is this in binary? It's 8, 9, 10, 11. So that's 11. And then let's have a number, the same number, right? It should get flipped eventually. See if it's unset. This will be just the number 3, right? So these can be my example numbers in my test. Here's a number with the third bit set. Here's a number without the third bit set. Okay. So that's 11 and 3. Let's remember those. And yeah, let's do a test for setting. So if we give it 3, if we give it the number 3, it should turn it into 11 because it's going to set that third bit, right? That's something we should test. So all right, int x equals 11. If I say set third bit on x, it should have set if I give it 3, excuse me, how do I want to do this? Yeah, let's do x equals 3 first. Let's do x equals 3. If I set the third bit now, it should be equal to 11, yeah? Assert true that x is equal to 11. Does that make sense? I've got to give some description of it. Set third bit with 3. So that's a test. Does that make sense? Any questions about the test itself? We're writing that before we actually write the set third bit implementation. That's all that TD is about. All right. What are some edge cases? I was thinking of it first, actually. What if x was already a number that had the third bit set? What should set third bit do in that case? Well, just make it a 1 again, like replace the 1 with a 1. It should still be 11, right? So that should be another test. If you call set third bit, if it's 11 now, sorry, let's say this. Say, all right, it's 11 now. Make sure it's 11. It should stay 11, yeah? So there are 2 good tests for that one. Does that make enough sense for us? And then let's make some tests for the other one. Is third bit set? So let's do assert true. Like, all right, if we call is third bit set on the number 11, it should be true, right? Because the third bit is set for 11. So 11 should give back true. And so we'll call this is third bit set on 11. And I think I have to get rid of this window, sorry. Just so that you can see it all. So that's one test. Let's do another one for one without the third bit set. So like 3 is a number without the third bit set. And so that should be giving back false. Right? There is, though, a cooler way to write these, because those equal equals true and equal equals false, well, first of all, this comparison is redundant. Let me show you how. Instead of doing it this way, let me copy and paste these and comment these out. Instead of it doing this way, like checking if it was true, you just like think about it. You want a condition. I want this is I'm asserting that this is true right now. And so it's kind of redundant to say equal equals true because I could have just said this. Assert true that is third bit set 11 results in true. Does that make sense? So that's what you can do. Just like make sure, like assert true that the third bit of 11 is set. That's kind of how you can read it. It's like this will result in true if it gives back true. So that's what we want to check. Make sure it gives back true. And then likewise with this one, you can't say assert is third bit set 3 because that would check if it was true, but you can assert that its negation was true. You see that? This is another way of checking, making sure that it was false. Assert that its negation results in true. Does that kind of make sense? So that's a cleaner way. What people tend to prefer to write it that way. So these are equivalent to the above. So there's that. And now I've got tests. All right, I've got tests, and they're all going to fail right now. I won't compile right now because I don't have implementations for these. So let's give stub implementations for these functions now. So they just like appease the compiler but fail all the tests. So what is a good function like implementation for this? It's a void function, so I don't actually have to have any body. Like that's going to compile. Cool. It's got a silly stub implementation, and then for this one we have to give back a bool. So let's just like return true. The third bit of any number is set. So of course those are both wrong. And then if I run my tests, we'll see test set third bit. Test is third bit set. We should have some failing tests now. And so it looks like some of them pass though, right? Just doing nothing is okay for this test, right? Because it should have stayed 11. That's correct to do nothing in that case. This is why you need multiple tests. It's going to fail for this one, of course. 3 does not magically turn into 11 by doing nothing. So that one fails, and then likewise, we have one that passes and one that fails for here as well. Like, all right, if we always return true, like it's going to be right sometimes. So that one passes, but obviously this one doesn't pass because the third bit of 3 is not set. And it should have been giving back false. So yeah, these are dummy implementations. And so we see red, we have to make green now. So now it's time to actually implement. Okay, so let's do that. How do we set the third bit of a number? Like take x and replace it with itself. And what bitwise operation, guys, do we use to set a bit? To force something to be a 1? It's an OR, good. So I'm going to OR this with a number with just a 1 right in the bit that I care about, the third bit. I'm going to shift it over there with the left shift. All right, so that's how we set the third bit. And then which bitwise operator do we use to check if a bit is set? It's going to be AND, yeah. Good. So I want to return whether or not, right? So first of all, let's just like spell it out. So to check if the third bit of a number is set, I'm going to AND with this number, right? A number with a 1 right there, and it's going to zero out everything except for maybe this one. If it was a 0, it would have made the number 0. But if it was a 1, it will make the number 8, I guess. So it's just like, was it 0 or was it 1? Or sorry, was it 0 or was it non-zero? Depending, okay? So what I want to do is take x and AND it with that number with a third bit set. So that's 1 left shifted by 3. It's a number with just the third bit set. And I just want to give back, like, I want to check, was this 0 or not? Because if it was set, then this was a non-zero result. Does that make sense? If this bit was set, then it would have given back 1, 0, 0, 0, which is non-zero. So we got to check that all that stuff resulted in something that was not equal to 0. And that's my answer. Return whatever that result was. Does that kind of make sense? Building it up like that? Do you yell at me if you have any questions? But that should check it properly. Just like AND it with that number, make sure it was non-zero. Because if it was 0, that means it was not set. So we want to make sure it's not 0. That means it was set. It gives back true when it was set. All right. So those are my implementations. I still got those tests. And we get them to pass. And then, then you would be like, you could refactor. So if you notice that something could be cleaner here, like maybe you hard-coded like the number 8 or something, you would refactor that and be like, oh, okay, that could be better represented like this, something like that. And so those are all the stages of TDD in a nutshell. And yeah, so it's like make stubs, make tests first, get the tests to pass, and then clean up your code afterwards. That's TDD in a nutshell. Are there any questions about that example? So I'll give you this code, of course, as usual. So it's a fun little programming paradigm. There are companies in the real world that write tests first and care a lot about tests. So that makes me happy. All right. So I think the last thing that I want to do, and make sure to do attendance if you have not yet, because I'll stop that after we do this. I have an exercise for you guys, just to be social. So I would like you guys to have a stand-up meeting with the people sitting next to you. So get together, have a daily scrum. I think it would be fun. So I'd like you to go around with the people sitting next to you, like a few people, get together, say hi, and try to talk about the following. What you're working on right now in the class, what you're struggling with maybe, and then like what you plan to do today or maybe even tomorrow on these things. All right? So that's like you giving a stand-up meeting, telling your boss what's happening, and maybe the people sitting next to you can be like, oh, you're having this problem? I also had this problem. Here's what you can do. That's the whole point of these meetings. All right? So like take like a minute per person, say hi, go and have a daily scrum, and I think it will be useful. So this is what you're going to do every day in industry. So please give that a try, and then we'll come back and wrap up. Ideally, stand up. Very nice. You're fired. Yeah. I hope that was useful. and you gain something. Like that's the whole point of it all. So thank you for putting up with that. I plan to stop attendance. Hope you learned something cool. And then yeah, let's just wrap up. What else do I need to do today? That's the end of these slides, so we'll start some new ones next time. And I think, yeah, I just want to give you a lab and then a new or talk about the final exam. And I usually do those things on Thursdays, so I'll just stop here, all right, and give you the rest of the time all to yourselves to do whatever you need to do.